Hey guys, today I'm going to teach you how to estimate square roots. In the past, we've looked at perfect squares and numbers whose square roots are whole numbers, but sometimes we don't have whole numbers. We could have numbers like the square root of 15, for example. So by the end of this lesson, you should be able to estimate the location of irrational numbers on a number line. So we'll go over what that means in just a second. But go ahead and get out your binder, turn to the math section, and get ready to take some notes. So let's jump right in by accessing our prior knowledge. Our perfect squares we looked at the other day. Remember, perfect squares are numbers whose square roots are whole numbers. For example, 64 is a perfect square because the square root of 64 is 8. 8 times 8 equals 64. Another example of a perfect square could be 4. Go ahead and look back at your other page or think in your head, what's another example of a perfect square? So you might have thought of 9, you might have thought of 25, you could have thought of 196. There's many different answers for this. They're all on that last page, so I'm just going to put 9 because I know that 3 times 3 is 9. So now let's look at what we're going to get into today. So now we have some things that are called non-perfect squares. So non-perfect squares are numbers whose square roots are not whole numbers. So for example, the number 6. I can't take the square root of 6 evenly because there's nothing times itself that gives you 6. 3 times 2 is 6, but 3 and 2 are different numbers. Remember, square roots are asking you what number multiplies by itself to give you the number on the inside. What number times itself. So there's nothing that multiplies by itself to give you 6. Another example of a non-perfect square is 45. Nothing times itself gives you 45. Another example could be 8. Nothing times itself gives you 8. So as we go through and just look at numbers, these are all numbers 1 through 100. I'm just going to go through and I'm just going to circle the perfect squares. Remember, these are your doubles. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9, and so on. Everything that I did not just circle in that top row is an example of a non-perfect square. So those are examples of non-perfect squares. I can't take the square root of 2 and get an even number because there's nothing times itself that gives you 2. So I'm just going to real quick go through here, and you can do this by yourself if you want to, but I'm just going to go through and I'm just going to circle perfect squares, and then you'll be able to see that everything else is not a perfect square. So everything circled, again, is a perfect square. I can take the square root of it and get a whole number come out. Everything that I did not circle is not a perfect square. So those are examples of non-perfect squares. You might want to screenshot this. I was going to say you might want to square root this. You might want to screenshot this and keep this for you. However, just because a number is not a perfect square doesn't mean that you can't take the square root of it. You can. We can use our knowledge of perfect squares to estimate the value of non-perfect squares. So there's never going to be an exact whole number that's going to come out of it, but we will get a decimal answer sometimes. So let me show you what I'm talking about. So this is going to be something you might want to use your calculator for. I just pulled up my phone calculator. I typed in 2 and then used this square root button. So it has a little 2 on this right here inside of it. And then there's an X in the middle. Remember, X is just a variable. That could mean you could put any number in. So that's the symbol for finding the square root of a number in your calculator. 1 times 1 is 1. 2 times 2 is 4. So the square root of 2 is something around here. And this is not a whole number. And it's not even a rational number. This is an irrational number. It doesn't make sense because there's nothing times itself that equals 2. Let me show you another example. Think about the square root of 25. The square root of 25 is 5 because that is a perfect square. 5 times 5 is 25. But there's nothing times itself that gives you 24. So just think about it before I show you the answer. If I type in my calculator, what's the square root of 24? It should be close to 5, right? It is close to 5. It's 4.898979485556. There's no pattern, there's no repeating, and it never ends. So this is, again, done by typing in 24 on the calculator and then putting in this square root button. You can type it on Desmos by typing in the square root button first and then typing 24 underneath of it, and it will come out with an answer, but it's not a whole number because 24 is not a perfect square. So using your calculator, this is really easy, but you could also use a number line without a calculator. This is just as easy, trust me. So look at these instructions. They say practice estimating, remember just guessing square roots in each of the following questions. So we're making educated guesses. It says estimate the value of the square root of 50. Use a number line to help you locate the closest perfect squares. We know that 50 is not a perfect square. So the first thing that we're going to do when we see a problem like this is look at the perfect square before and after 50. Let me show you what I mean. So 50 is not a perfect square, but we're going to look at the number right before, 49. Then we're going to look at the next closest perfect square. So let's just keep going down. The one above it is 64. So the square root of 50 is in between the square root of 49 and the square root of 64. So I'm just going to put those values on the number line. I'm just going to put the square root of 49 and then the square root of 64. I know that the square root of 50 is between those. I also know that the square root of 49 is 7 because 7 times 7 is 49. And I know that the square root of 64 is 8 because 8 times 8 is 64. So I know that square root of 50 is between 7 and 8. The next step is to determine which perfect square it is closest to. That means, is the square root of 50 closer to 49 or 64? So because 50 is only 1 away from 49 and 50 is 14 away from 64, guess which number 50 is closer to? 49. So the square root of 50 will be closer to 7 than to 8. So it'll be closer to 7 than to 8. It's just a little bit over 7. So I'm going to check this with a calculator. So when I type this in the calculator, I got 7.07 and so on. So it's, like I said, just a little bit over 7. And so a good estimate, remember that's what this sign means, it's just approximately, it's about 7.1, you could think. It's just a little bit over 7. So if you didn't have that calculator, you would still realize it's just a little bit over 7. So we're going to try to do all these today without a calculator. And then you can use a calculator to check if you need to, since this is just practice. But I know that on a test, this is a no calculator part. So let's try to make sure we really get it without a calculator. So let's do number 2, and I want you to follow along with me. Pause before I tell you an answer so you can do it yourself, and then press play to check. So the thing says to estimate the value of the square root of 22. So the first thing we're going to do is figure out the two numbers that it's between. Go ahead and do that now. Okay, so by now you should have thought about it yourself, but I'm going to go ahead and look at it on mine. So I'll know I'm looking for the square root of 22. I know that the one right above it is 25. Then the one closest below it is 16. So those are the perfect squares that it's between. So I'm just going to write those above it, the square root of 16, and then this one above it is the square root of 25. And I know the square root of 16, I know the square root of 25. So if you know that, go ahead and write that underneath of it and plot those on the number line. Okay, so by now you should have paused the video, thought to yourself what the square root of those are, and then press play when you're ready to check. The square root of 16 is 4, the square root of 25 is 5. And so that means square root of 22 is between 4 and 5, but it's closer to 5. 22 is closer to 25, so it's closer to the number 5. So the decimal estimate of the square root of 22 would be about 4.7, let's say. So it's about 4.7 because it's closer to 25, but not quite. Number 3, we're going off a little bit. It says estimate the value of 103, so we're going off of that chart that goes up to 100. So you have to think a little bit about this one. So step 1 is to check to make sure that square root of 103 is not a perfect square. It is not, because there is not a number times itself that equals 103. So I need to think about which two numbers is it between. So which two perfect squares does it come between? I'm going to look at my chart. Let me erase that. And I'm going to see that 103 would go about here. So I can see that it's close to the square root of 100. But what is greater? What is the next square root greater than 103? Think about it. When we went through these, we did 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on. We got up to 10 times 10. So the way to find the next closest square root would be to do, 11 times 11. So 121 is the next perfect square. So 103 is between 100 and 121. So I'm just going to go ahead and plot those on the number line. So between 100 and 121. I know that the square root means what number times itself gives me the number that's underneath of the radical, or the square root symbol. The square root of 100 is 10. The square root of 121 is 11. So I know that the square root of 103 is between 10 and 11, but 103 is closer to 100, so it's closer to 10. The decimal estimate of square root of 103, therefore, would be about 10.1. Anything close to that is a good estimate. So I want to give you the chance to practice solving these by yourself. So you have 4 questions. I want you to try 4, 5, 6, and 7 all by yourself. Whenever you get stuck or need help, I want you to press play and then work on it along with me, and then pause again whenever you think you've got it. So go ahead and pause now. Okay, so by now you should have paused and practiced solving number 4. So it says, which of the following square roots best represents point A? All of my options are multiple choice and they are all square roots. So I need to look at these numbers on the number line as square roots. So instead of looking at this as 3, I want to think what perfect square gives me 3. So I know that 3 times 3 is 9. So the square root of 9 equals 3. I'm going to do the same thing for 4. I know 4 times 4 is 16. So I know the square root of 16 gives me 4. Now I'm going to look at point A. Point A is close to 16. So I'm going to look at all of these multiple choice options and look for the one that is closest to the square root of 16. That would be C. So the square root of 15 is about 3.9. So number 5 is just a little bit harder. It says, which of the following will be the best estimate for the square root of 198? Remember, we're trying to do this without a calculator. So the first step is going to be to draw your number line. You want to pick the 2 perfect squares that are between the square root of 198. If you needed help getting started, pause the video now, figure out those numbers, and then come back whenever you're ready to check. So I didn't know off the top of my head what 2 numbers it was between. So I start looking at my doubles and I start looking at 12 times 12 is 144. And then I keep going, see if I can get closer to 198. 13 times 13 is 169. 14 times 14 is 196. So I know I'm getting closer. So I know that one of these is going to be 14. And then I know I need to do the next one. 15 times 15 is 225. So I'm going to be looking at the 2 numbers on either side of 198. So I'm looking for 196 and then 225. So I just plot those on the number line. I know that the square root of 196 I just did, that's 14. And I know the square root of 225 is 15. And then I'm looking for where approximately is the square root of 198. It's close to 196, so it's really close to this. So it's probably about 14.1. It's just above 14. So number 6 is just asking between which 2 integers, remember those are positive or negative whole numbers, would each of the following lie. So the square root of 90 is not a perfect square, so I'm going to have to think of the 2 perfect squares on either side of it and then estimate. I know by looking at my chart that 81 is a perfect square, and I know by looking at my chart that 100 is a perfect square. I know that the square root of 81 is 9, and I know that the square root of 100 is 10. So because 90 comes between 81 and 100, I know that the square root of 81 is 9 and the square root of 100 is 10. I know that my number, the square root of 90, is between 9 and 10. So remember, the square root is a whole different operation. It does not mean multiply. It does not mean divide. It's a whole nother operation. It's a new operation in math. It just means what number times itself gives you the number that's underneath of this symbol. There is no perfect number. There is no whole number, but I know it's between the numbers 9 and 10. So I'm going to go ahead and just give you the answers for the next 2. The square root of 175 is between 13 and 14. And then you have C, which is the negative on the outside of the square root symbol, and then square root of 12. So we'll look at the square root of 12 first. The square root of 12 is between 3 and 4, and because it's a negative, it's going to be negative 3 and negative 4. So it's the same thing, you just keep the negatives. So number 7 is probably the hardest one on this page. It's a word problem. It says Rebecca bought a square table. So anytime you see anything about squares in math, now in 8th grade and up, they're going to start asking you to find the square root or square the number for her kitchen. The area of the table surface is 65 feet squared. What's feet squared mean? It means it's already been done. It means this is the area. So if I was going to draw this as a picture, which you should be doing every time you see a word problem, is I was going to go ahead and just draw the square approximately and then put 65 feet squared on the inside. Then it says, what is the approximate length of one side of the table? So I saw a lot of people the other day making mistakes, dividing by 4. If you do 65 divided by 4, you're going like this. That's not what we're doing. We are finding the side lengths. So we are finding the length of one side. That means the only operation that can give me the length of one side, since its length times width, I need to do the square root of 65. So step 1, the first thing I want to ask myself, is this a perfect square? Is there a number times itself that gives me 65? The answer is no, but I can get close because I know that 8 times 8 is 64. So 8 times 8 is 64. So the square root of 64 is 8. And I know that 9 times 9 is 81. and I know that the square root of 81 is 9. So I know that this number, square root of 65, is between the numbers 8 and 9. And since it's closer to 64, I'm going to say that it is approximately 8.1 feet. That's the length of one side. So about 8.1 times 8.1 gave me an approximate area for the square table. So for number 8, this is going to be the last one. This is going to be a very helpful tool for you to use. So you're going to want to go ahead and just fill this out along with me, and then you can answer the question. So it says create and label a point on the number line to represent an estimate of the following square roots. So I'm going to start by just creating a number line with square roots instead of these whole numbers. So instead of this being 1, I know that's the same as the square root of 1. Instead of 2, I know this is the same thing as the square root of 4. So remember your doubles. 3 times 3 is 9, so I know the square root of 9 is 3. So I'm going to make a square root number line. I'm going to go ahead and make this because when we answer the question, it'll be a lot easier if you can see the square roots above them. So the square root of 36 is 6. 7 times 7 is 49, so the square root of 49 is 7. 64, 81, 100, and then 121. So I'm going to take each point, and a mistake that I see people making is that they'll go, okay, square root of 5. Well, that just goes on 5. 5 is a 5. This does not say 5. This says the square root of 5. So point A is going to go between the square root of 4 and the square root of 9. And it's going to be about here because it's closer to 4. 5 is closer to 4. So this would be where point A goes. So the actual number is close to 2. But remember, we don't have an exact whole number, rational number answer because we know that there's nothing times itself that gives you 5. So go ahead and pause and try it yourself, and then you want to press play whenever you're ready to check them. Okay, so point B is square root of 88, so it's between these two numbers, square root of 81 and the square root of 100, which is the same thing as 9 and 10. And we're going to go ahead and we're going to realize that it's closer to 9, but not by a lot. So we're going to put it a little bit closer to 9, but not by a whole lot. Let's look at C. It says the square root of 17. So we know that's really close to the square root of 16, so it's right above the whole number 4. I'll go ahead and label my points. Make sure you've labeled your points so you don't get confused. Point D is the square root of 118. So I know that that's between the square root of 100, the square root of 121. I know that it's a little closer to 121. So I'm going to put it right here. So it'll be 10 point something, but the 10 point, it's going to be greater than 10.5. Then I'm going to look now at the last one, point E. Square root of 56 is almost right between 49 and 64. And you can count on either side to check, but it's going to be almost right in between, maybe a little closer to 7. So this is point E, and you are done creating this number line and labeling stuff on it. So I hope that number line is helpful. It might be helpful for you to keep that and look at that as you go through the next practice problems today and tomorrow. All right, guys, that's it. If you made it to the end of this video, please put your favorite ice cream flavor in the comments. Today we went over estimating square roots. We looked at estimating location of irrational numbers on a number line. Irrational means it doesn't make sense. So remember, these irrational square roots are numbers that have nothing that multiplies by itself to get that number, but we can still get the square root of them, and we can locate them approximately on a number line. So now I want you to go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.